looking at partial derivatives, which is a way we can differentiate when we've got a function of more than one variable. So here, z, this notation just means z is a function of x and y, and the way we write partial derivatives are with this sort of curly d, so dz, or partial dz, partial dx, and that means that you treat any other variables that are not x, so y in this case, as a constant, and then you just differentiate as you would with respect to x, and then we define partial dz by partial dy similarly, where you treat x as a constant and you differentiate with respect to y. I think the best way to demonstrate this is just with an example. So say we take z is equal to 4x cubed y squared, partial dz by partial dx. Well, y here is just a constant, so our constant is just 4y squared, right? And then to differentiate with respect to x, well, we multiply down by the power and reduce the power by 1. So 3 times 4, so that gives us 12y squared x squared, okay? That's that. And then we want to find partial dz by partial dy. So now we're keeping x constant, so our constant is 4x cubed, and this is, well, you take the 2 down from the y, so you get 8x cubed y. Okay, so that's a pretty simple example. In future videos we're going to look at the interpretation of the partial derivative, like graphically, because we know if we've got y is a function of x, then dy by dx is equal to the gradient, right? So we want to find sort of what that means, what our partial derivative tells us, and we're also going to look at some chain rule stuff and other uses of partial derivatives. But I hope this was useful as a quick introduction to partial derivatives. If you do want to see the future videos on this topic, be sure to subscribe. If you did enjoy, please like the video. If you didn't, then dislike it, whatever. That's what that's for. And I hope to see you in the next one.